let us talk about vector projections. Well, let's just draw the coordinate plane first so we can talk about this more easily. So this is the y-axis. And the horizontal axis is, well, obviously the x-axis. And then we're going to have two vectors, so let me just draw my vectors. Now, vector 1, or vector A, let me just call that vector A, is going to be at the first quadrant, be in the first quadrant. So that's vector A. And then vector B is still going to be in the first quadrant for simplicity's sake. That's vector B. And then I'm going to call the angle between vector A and B theta. So, essentially, the projection of vector A onto vector B, so firstly it has a notation PROJ for projection of vector A onto vector B. That's our notation. So this is a vector, actually. This is a vector. So let's just name that vector P for projection. Now what's vector P then? So we start at the endpoint here of vector A, and then we draw a perpendicular line down to vector B. Then we land at this point, right? Well, the resulting vector here, starting from the origin and ending at this point, is vector P. That's vector P. So that is vector P. Okay, so we're going to try to find a formula for vector P. So we need a formula right now. So we need to use the angle theta because it's the only thing which connects vector A and vector B and vector P together. Vector A has a theta angle between this vector over here. So this is the only angle relationship they have between each other if we didn't draw this altitude. The altitude is also important because we're going to use trigonometry functions. We're going to use cosine theta. What is that? That is, well, that's the magnitude of vector P over the magnitude of vector A. Right? Now we also know that we have dot products, which include cosine theta. The dot product of vector A and B is equal to the magnitude of A times the magnitude of B times cosine theta. We know that, therefore, the cosine theta is equal to the dot product of vector A and B over the product of the magnitude of A and magnitude of B. Well, we know that these two expressions on the right-hand side are equal because cosine theta obviously equals to cosine theta. So, we just put them together. We have the magnitude of P over the magnitude of A. Actually, we'll just directly multiply magnitude of A for both sides. Then we get the magnitude of P is equal to the dot product of A and B over the magnitude of B. Well, that is just the magnitude of P. So we have the magnitude of vector P. But we want the direction, because only when we have the magnitude and direction of vector P, when we can calculate the components of it. So, well, the direction is just an angle, right? It's this angle here. So maybe I should name this angle, well, let's just name this angle phi. This is another Greek letter. I'm going to name this phi. Okay, so I named my angle phi. And then, how do I calculate this angle? Well, the same thing. We use cosine and sine and all that stuff. Well, we already have information about vector B because that's supposed to be given in the problem. If it isn't, then the problem is a different type of problem compared to this type we're talking about here. So, assuming that this condition of vector B is given, the components is given, then we know the x and y axis, right? Then this is actually the y coordinate. And this part is the x-coordinate. Well, because this is the right angle, and this is on the x-axis, so this is the x-coordinate, the x component of vector B, and this is the y component of vector B. Well, therefore, this means that, well, not cosine, tangent phi is equal to y over x. So that's y over x. And then, if that's y over x, and we have ideas about y and x because we know the components of vector b, so we already know this. We can figure out angle phi. And angle phi is just going to be the inverse tangent of y over x. So therefore, well, this angle phi is the same for vector b and vector p because vector p is literally a part of vector a. A part of vector b. So vector p also has this angle phi as its direction. So we already know angle phi because we know y and x. And we already know the magnitude of p because we know these values here. Now therefore we get that. So we therefore get that, well, vector p is equal to, so it's equal to cosine theta, no, not cosine theta, cosine phi times, well, the magnitude of p times cosine phi, magnitude of p times cosine phi, then the magnitude of p times sine phi. Okay, so that's just our answer. Like, we've got our formula. Another thing I want to talk about is comp, which is this thing over here, C-O-M-P, comp. That is still the projection of vector A over vector B. However, this gives us the magnitude of vector P. So that actually, this formula is actually over here, right? And then this formula is over here.